End behavior of a polynomial is all dependent on its degree and its leading coefficient. So here in the table, we have a description of all of the polynomials classified by their degrees. So for our degree of 1, our linear functions, if we look on the left side of the graph where the x's are negative, our function is going down, so those y's are getting negative as well. So it would be going down to negative infinity. On the right side where our x's are positive, the function is going up to our positive y's, so that would be our positive infinity. For our degree of 2 for our quadratic functions, regardless if the x is negative or positive, both ends are pointing upward to the positive y's, so they both would be growing upward to positive infinity. For our degree of 3, it's very similar to what we had for our degree 1 linear functions. When the x's are getting negative on the left side, so is our function, so they would be going down to the y's that would be going to our negative infinity. On the right side, where our x's are positive, the graph is growing upward to where all of the y's are positive, so they'd be growing up to our positive infinity. Our quartic functions, so our degree 4 terms, are exactly the same as our degree of 2 terms. And same with our degree of 5 terms, the quintic functions, those are the same as the cubic as well as the linear. So if you notice there is a trend between the odd degrees, 1, 3, and 5, and the even degrees of 2 and 4. So here on the next table, we have everything classified by either the degree being even or odd, and then we do have a difference with the leading coefficient being positive or negative. Remember in previous chapters when we have had a negative number in the beginning of our equation, the negative has indicated a reflection over the x-axis. So the same thing is going to be happening here. So if it is a negative leading coefficient, we are going to have a reflection going on. So for any leading coefficient that is positive, that's what we have here on the top row. Odd degrees, so like our degree 1, degree 3, and degree 5 that we saw in the previous table, as our x's were negative, the function itself was also going negative because it's going downward to those negative y values. And then as our x's were going positive here on the right side, the function itself was also going positive because it is going upward to where those y's are positive. If we have an even degree, like we did for degree 2 and degree 4, our quartic and our quadratic functions, even though the x's are different, so as the x is negative and as our x is positive, the function itself is going positive on both sides. So both y's are going to be up in the positive direction. Here in the bottom row, we have a leading coefficient that would be negative. So it's going to be the opposite of what we saw in the previous row. So here, when we have an odd degree, as my x's are negative, my function this time is actually going to be growing positive to those positive infinity y's. And then as our x's are getting positive, our graph is actually going downward to where our y's are negative. Then when we have an even degree, the same thing, it is going to be opposite. So even though I have a negative x and a positive x, both of the y's are going to be growing downward to the negative direction. So now when we complete these two examples, we're going to be using that table in the previous slide to help us determine the end behavior. So remember, it's all dependent on the leading coefficient and the degree. So here in A, my leading coefficient is 1, which is positive, and my degree is 4, which is even. So if I flip back to the table, I want to use the first row, second column. So that would be as my x's are going to be negative, our function itself is going to be growing in the positive direction. Same thing happens as our x's go positive, the function itself is still going to be growing positive as well. In letter B, my leading coefficient is -3, which is going to be a negative number. And my degree is also 3, which is an odd number. So we're going to be in the second row, first column of our table. So my end behavior, as my x's are going negative, my function is actually going to be growing upward in the positive direction. And as those x's are getting positive, the function is going to be growing downward in the negative y direction.